Hello there, Mr. Sutton here, bringing you the 2021 MCAS solutions. For this question, we're given some triangle, NPQ, on our coordinate plane, and we're told that it's going to be dilated with a scale factor of 2 with respect to the origin to create a new triangle, N prime, P prime, Q prime. We want to know which of these graphs shows us this new triangle. Now, one thing to notice on all these graphs is that NPQ, that triangle, is the same on all of the graphs. It's the same exact triangle. So really the only thing that's changing is this other triangle. Now, when we're dilating with a scale factor of 2 with respect to the origin, basically that means we are multiplying all the x and y values of our original triangle by 2. So probably the easiest way to figure out which of these is the new triangle is just to take a look at the points of NPQ and see, if the new triangle here really is all those coordinates multiplied by 2. So the point N here, this is -2, 1. And in choice A, we're just going to look at choice A first. That turns into -4, 2. Now it looks like -2 and 1 both got multiplied by 2 to give us n prime. So far, choice A is looking pretty good. But we can't just be satisfied with that. We have to check out these other points because they don't have to be the same kind of relationship. So point P is 1, 2 initially. That changes into 2, 4. And that is also everything multiplied by 2 to get that new point. So that also checks out. Finally, point Q, that's going to be 1, -2, and Q prime is 2, -4. So that also got multiplied by 2 everywhere. So choice A looks like it's our answer, but just to be on the safe side, we can check out the other ones. So in choice B, our initial point of -2, 1 for n turned into -4, 3. Now, the trouble with this, -2 times 2 is -4, but 1 times 2 is not 3. So choice B is no good just based on that 1 point. For choice C, we still have that same initial n value, but now in choice C, that n is turning into -4, 1. And now this 1 should have been a 2 if we were multiplying this 1 by 2. So choice C is no good either. And then for D, we have -2, 1. Turning into -3, 1. So both the x and the y coordinate are wrong for n prime. So based off of all this, choice A is what we're looking for. For this problem, we have Sylvia planning to use a 4-year loan to purchase a car. The price initially is $8,575, and the interest is going to be $1,036. Now, the way that we're going to actually figure out her monthly payments, of which there are going to be 48 of them, is she's basically going to add these two together. She's going to combine the price of the car and the amount of interest. This is a little bit of a simplification of how you actually calculate your monthly payments, but whatever. Let's go with this. The key on this one now, after we add these together and then divide by 48, the key is we have to do this without a calculator. So we're actually going to have to estimate each of these things before dividing. So let me call the price of this car, let me round that off to $9,000. If we need to get more precise and round it to something like $8,600, we'll do that if we can't pick an answer choice based off of doing it this way. Now for the interest, I'll call that $1,000. And that means that the total that she'll pay, these two things combined, will round that to $10,000. Next, for the number of monthly payments, 48 doesn't sound fun to divide by, so let's call that 50 instead. And to do this calculation, then, we're doing 10,000 divided by 50. That'll tell us how much each payment individually is. So if we just think about canceling out one of these zeros, we've basically got 1,000 divided by 5, which is going to come out to 200. So that's $200, choice B. For this problem, we're given the equation here, and we want to know which two of these values is going to make this thing true. So one way to do this, if you don't really know how to solve this, is just start plugging these in for x and see what makes this equation come out the same number on each side. But if we want to solve this kind of the old-fashioned algebra way, since this is an x squared, a good idea would be to zero this out, get everything on one side. I'm going to move everything over to the right side just so I can keep my x squared positive. So I'll have an x squared, and then let's see here, I have a 2x over here. I'm going to subtract a 5x. 2x minus 5x gives me a negative 3x. And I've already got a positive 1 over here on the right side. I'm going to add 1 to get this 1 over here. So 1 plus 1 gives me a 2. And now I'm just going to shift everything over and put equals 0. I could put 0 equals, but it just feels weird putting 0 equals on the left side. So I'll just switch sides and make that the right side. All right, at this point, we have a quadratic. There's lots of ways of solving that. We could use quadratic formula, but that's kind of overkill. This one looks like it'd be easy enough to factor. So two numbers that multiply to 2 and add up to negative 3. That would be negative 1 and negative 2. So x minus 1 and x minus 2 is what we can split this into. And then if we set each of these individually equal to 0, 1 minus 1 would give us 0. So x equals 1 is one of our answers. And 2 minus 2 would give us 0. So 2 is the other answer for x, which means we're going to be picking choices D and E. On this problem, we have a survey given to 15 customers at a store. They rated their satisfaction on a scale from 1 to 10, and here are the results in this list. And they want us to just complete a histogram showing the distribution of these ratings. So probably the easiest way to do this is to put these in order and then just count up how many fall into each of these categories. Notice we have a 1 to 2, 3 to 4, and so on and so forth. We're just going to count them up. So I'm going to cross these off as I put them in my list here. So we've got a 1, that's our lowest number. Let me cross that off. And then the next lowest number is 2, so we'll cross that off. After 2, doesn't look like we have any 3s. Do we have any 4s? Doesn't look like any 4s. Then we have a 5 though, so we have a 5 here, and here's another 5. Cross that off. There's no more 5s, but there is a 6 right here. So let me cross that off. And after that, we've got a 7. And we have another 7 right here. Cross that off. And a 7 here. After that, we have an 8 at the beginning of the list. And another 8 all the way over here, hidden in the middle. And then finally, we have a 9 in the beginning. And another 9 right here. And another 9 here. And then finally, we have a 10 and a 10. Okay, so going through and counting these up, the first category is the 1s and the 2s. There are 2 of those, so I'll just draw a little rectangle coming up to 2 here. Next, there's no 3s and 4s, so we'll leave that blank. 5 and 6, there's 1, 2, 3 of those, so that comes up to here. And then for 7 and 8, 3 7s and 2 8s, that's a total of 5 in that category, so this is going to come to the 5th line. And finally, there's 5 of these 9s and 10s combined, so that's also a 5 for that rectangle. For this one, we have a system of equations, and if we notice real quick, we have a line and some kind of quadratic here. Turns out this is a circle, basically trying to figure out where these cross when we're trying to find the solutions to this system of equations. Now, they gave us a list of 5 different possibilities, and they're telling us that 2 of these are actually correct. If I'm being totally honest, probably the fastest way to do this is just to plug all of these into both of these equations until we can eliminate 3 of them. That'll happen pretty quickly. Like right off the bat, if you plug 0, 0 into this second one, 0 plus 0 does not equal 20. But let me also show you the way to do it algebraically in case you're interested in something like this without multiple choice. Also keep in mind that you might have to do one of these without multiple choice to choose from anyway. So it's good to have this other way in mind. So to solve this using algebra, I'm going to use something called the substitution method. Basically, I want to make sure one of my variables is by itself, which this y is. And now wherever I see a y, I can replace it with the negative 1/2 x. The idea here is that I want to try to get one of these equations to have only a single type of variable instead of 2 different variables. So down here, I've got this y squared. I'm going to replace that with negative 1/2 x. So I'll rewrite this second equation as x squared plus parentheses negative 1/2 x quantity squared equals 20. So it's just this one little thing I swapped out. Now if I square this, I have to square both the negative 1/2 and the x. Negative times a negative is positive. 1/2 times 1/2 is 1/4, and x times x is x squared. So this is 1/4 x squared. To solve this equation, probably the fastest way on this one is going to be to combine these x squareds together and then use square rooting at some point. So I have to get like denominators here to do this. I can think of this 1x squared as a 4 over 4 x squared. 4 over 4 plus 1 over 4 gives us 5 over 4 x squared. Next, before I square root anything, I want to multiply both sides by something to get rid of this 5/4. So I will multiply by the reciprocal of that, 4/5 on both sides. That cancels out the 5/4 because it just comes out to 1. Over here, 20 divided by 5 is 4, and 4 times 4 is 16. 16 is 4/5 of 20. So now we have x squared equals 16. To solve this, I have to square root both sides. And when I do that, I have to remember that when I use square rooting to solve an equation, there's a plus and minus that I have to throw in there because it's not built into the square root. So this is going to be plus or minus square root of 16, or plus or minus 4. Those are my two different x values. Taking a look at my answer choices, there are only two answer choices that have either 4 or negative 4 in them. That would be B and D. But if you just want to kind of take this through and finish it out, I'm going to plug each of those x values into this other equation, y equals negative 1/2 x, and just to see what's going to happen there. So I can write y equals negative 1/2 times, there we go, negative 1/2 times negative 4, one of my x values. That's going to be positive 2. So we have the point then negative 4 comma 2. That's one of my answers. That was choice B. And if I plug in positive 4 to that first equation, now I have negative 1/2 times 4 giving me negative 2. So that also gives me the point 4 comma negative 2 as a solution, which was choice D. So we have B and D for our answers. This problem is a free response with 4 parts based off of this graph here. So just getting the lay of the land, we have the lines F and G on here, and they've got these points P and Q, which they've labeled, if you couldn't read the grid lines there. They also actually went all out here and gave us the equations of lines F and G. F was y equals 2 because it's a horizontal line going through 2. G is y equals 2x minus 1 because it has a y-intercept of negative 1 and a slope of up 2 over 1 going on here. So for the first part, part A, they want to know an equation of a line that's parallel to line F and passes through point P. And then they want us to tell us how they got the answer. So the key here is parallel means we're going to have the same slope. So that means I need to write the equation of another horizontal line. Specifically, I need a horizontal line that goes through this point P, that goes through the point negative 2 comma negative 1. To write the equation of a horizontal line, it's just going to be y equals the y value of whatever point you want it to go through. The y value in this case is negative 1, so we would just write that line as y equals negative 1. And that's our answer. For part B, they want us to write the equation of a line that's parallel to line G, this line here, and passes through point P, and then explain how we got the answer. So I think the easiest way to do this, since we're going through a point that is not the y-intercept, and the line that we're writing an equation for is not going to be just a vertical or horizontal line, I think we're going to want to use the point slope form of a line. So that would be y minus y1 equals m times x minus x1. This is really handy if you just have an x and a y that you want to plug in along with a slope. So we actually know x1 and y1 already. That's just the x and the y value of the point that we're going through. For m, that's going to be the slope of our new line. Again, parallel means we have the same slope, so we need to figure out the slope of g and then just recycle that for this equation. So for g, there's two ways to find it. You can just look at the graph. We're going up 2 over 1, up 2 over 1. So that's a slope of 2 just visually. But also, if you look at the equation, 2 is in the m spot for the g equation, which is in y equals mx plus b form. So any way you look at it, 2 is the slope of line G. So putting all this together then, we're going to have y minus y1. So that's y minus negative 1. So we're going to have y plus 1. And then our m value hit a slope of 2. And then we're going to have x minus negative 2, so x plus 2. This is good enough as equations go. If you wanted to put this in y equals mx plus b form, you could distribute this 2 and then add or subtract the 1. So that would be 2x, and then this would be a 4 minus 1 would give us a positive 3. So that's another form, but they didn't say you had to put it in that form, so honestly I would just leave it in point slope form. For part C, they want an equation of a line that is perpendicular to line F and passes through point Q, and then explain. Perpendicular means it meets it at a right angle. So if you are starting with a horizontal line, the line that's perpendicular to that is going to be a vertical line. So we need a vertical line then, and we need one specifically that goes through this point. Now the setup for writing a vertical line, it's going to be x equals a constant. It's going to be x equals the x value of whatever point you want it to go through. In this case, we want it to go through 3 comma negative 2. So we're just going to write x equals 3. And that's all we need for this one. For part D, they want a line that's perpendicular to line G and goes through point Q. This is in some ways easier or trickier, I guess, depending on what you're kind of ready for with this perpendicular stuff. We can't just do like a vertical line again like we did for part C. Now we need, because we have a slope here that's not horizontal, we need to take the opposite reciprocal of whatever the slope of G is. So since the slope of G was 2, the opposite reciprocal of that is going to be negative 1/2. So G slope is 2, so negative 1/2 then is going to be the perpendicular slope. So that's what we're going to plug in with our point slope form. So we're going to have y minus negative 2 this time. That's the new y value, so y plus 2. We have our m value of negative 1/2. And then we're going to have x minus x1, so that's going to be x minus 3 in this case. So again, we're just using the same point slope formula that we used in part B. Now again, you don't have to turn this into slope intercept, but if you wanted to, distributing this negative 1/2, we would have negative 1/2 x plus 3/2, and then 3/2 minus 2 would be a negative half. So negative x minus a half would be another form of this line that you could use. On this one, we're told that triangle RST is drawn on a coordinate plane. We want to figure out whether each transformation in this table performed on that triangle will give us a congruent figure, so a congruent result, a shape that basically is the same. So for each transformation, they want us to select congruent or not congruent. Now, just kind of general knowledge about transformations and what changes shape and what doesn't. If you have a dilation or a stretch with a scale factor that is not positive or negative 1, that's going to change the shape. You're either making the shape bigger or smaller by dilating by something other than negative or positive 1. So that would be a non-congruent result that we would get there. Any other transformation, a dilation with 1 or negative 1, or a translation or a rotation or a reflection, all the other transformations that we do don't actually change the shape. They might change which way it's facing, where it is, but they're not going to change the actual shape, the actual sides and angles of the shape. So taking a look at our options here, first one, dilation with a scale factor of 2, that's not a scale factor of 1, so automatically that's going to give us something that is not congruent. This next one, we have a rotation. Any rotation is going to give us a congruent shape. And a reflection, again, any reflection is also going to give us something that's congruent. For this one, we're being asked which of the following solutions or systems has the same solution as this original system. One way to do this problem would be to actually solve this system of equations, get the x and y value that makes it true, and then solve all 4 of these. That's going to take a while. You could do it, though. Another way, a slightly faster way, would be to compare these systems of equations and see which of these 4 systems of equations we could get by doing something legal to this first system of equations, such as adding it or multiplying it by the same number. So one thing to notice right away is if we look at this first equation, the top equation here, looking at all the answer choices, that's exactly the same in all of them. So really we don't have to worry about anything that happened to that first equation because it's been duplicated. It's really then that second equation that we have to see how did that change to get each of these 4 answer choices. So looking at choice A, 4x plus 3y equals 24 being our bottom equation there, is there something I could do to my initial bottom equation to get the one in choice A? Well, to get from 2x to 4x, I would have to multiply everything by 2, which would explain how the 24 got there based on the 12 being there initially. But 3y times 2 doesn't give us 3y, so choice A doesn't really work. Over here with choice B, we started with 2x, we ended with 2x, but then the y's are different, so choice B doesn't really work either. With choice C, we got 4x from 2x, we got 3y turning into 6y, so that's also times 2, and then 12, 24, that's also times 2. So our bottom equation in choice C was multiplied by 2. We multiplied the original equation by 2 to get this. So choice C so far looks like it's equivalent. Let's just take a look at choice D just to be on the safe side. Here we have a 2x and a 12, which is the same, but this 9y is different. So we couldn't get choice D by multiplying this bottom equation by anything. So we can confidently go with choice C then. On this problem, we're given this data set, and they're telling us that there is an outlier in there. They want to know what best describes the effect on the mean of the data if the outlier is removed. Well, they didn't tell us who the outlier was, but in general, that's going to be the data item that is furthest away from the center of this data. So these are actually arranged in order, which is nice. Our median here is 45, so the outlier is going to be whoever's the furthest away from that. 20 is one candidate. That's 25 away from there. 75 is 30 away from 45. So if we're telling us that there's an outlier, 75 has got to be it. It's the biggest outlier, so that must be the one that they're talking about. Now, what happens if we remove 75 from this data set? Looking at my answer choices, we're talking about the mean either increasing, decreasing, staying the same, or just not having enough information to make a conclusion. So the mean or average, what's going to happen to that if I take away this 75? Since 75 is the maximum item here, it's the highest item, removing it is going to drag the overall average down because all the numbers are smaller now that are being averaged together. So that's going to drag our average down, which is to say it's going to decrease the mean. So choice B. For this one, we have an arithmetic sequence given by this function right here, 3 plus 2n. They want to know the 5th term of the sequence. Well, the easiest way to figure out the 5th term of the sequence is just to plug in 5 to this formula here. Because the way this arithmetic sequence is represented, you basically plug in the term number and it tells you the value of that term. So if we plug 5 in there, we've got 3 plus 2 times 5. That's 3 plus 10, so that's going to be a grand total of 13. Choice A. For this problem, we have a two-part problem using the numbers in these boxes here. So first part, we want to know what the square root of 9 plus the square root of 9 is. So let's see here. Square root of 9 is 3, so this is 3 plus 3, which is 6, which is one of our numbers, so that's good. For this part of the problem, we're trying to multiply 2 radical 3 by 2 radical 4. One way to do this would be to multiply the stuff outside the radicals together and the stuff inside the radicals together. So that would give you 4 radical 12. But then you would need to simplify the radical 12 because 12 is divisible by a perfect square. So that's one way to do it. Maybe a faster way is actually just to recognize that the square root of 4 is 2. So this is really 2 times the square root of 3 times 2 times 2. Well, we have 2 times 2 times 2 outside radicals, so that's 8 radical 3. And you can't really simplify radical 3 any further, so then 8 and 3 are the numbers we would pick to put in these boxes to drag and drop, and this one's done. On this one, we want to know which of these expressions is equivalent to this expression. Really all you have to do for this one is distribute this negative 3x. So we have negative 3x times negative y. That's a negative times a negative is positive. So we have 3xy for that. And looking at all the answer choices, we see that they all have 3xy's. So really, it's just going to come down to the correct signs on this. Negative 3x times positive 4. Negative times a positive is negative 12x. That doesn't match any of the answer choices, but we can actually reverse the order that we write these in as long as we're careful about it. So we can write negative 12x plus 3xy. Notice that they both keep whatever sign they had before, and that's going to match choice D. For this free response problem, it's all based off of Nora, Owen, and Peyton doing some stuff with expressions. A lot of PEMDAS going on here. So for the first part, we have Nora writing square root of 3 squared. We want to know the value of this and how we got the answer. A couple of ways to explain this, but basically we're multiplying radical 3 by itself, which should give us the square root of 9. And we know the square root of 9 is 3. Another way to explain this is that square root and square are inverse operations, so they would cancel each other out, leaving us with 3. For this one, we have Owen writing the cube root of 2 to the 6, and we want to know the value of this. So one way to do this would actually be to do 2 to the 6th power, which is 64, and then maybe you know that the cube root of 64 is 4. That's definitely one way to show your work on this. Another way you could do this, since we have a radical and an exponent, we know that we can turn that into a fractional exponent. We can rewrite this as 2 to the 6 divided by 3 power. 6 divided by 3 is 2, so this is really 2 squared, which is, again, 4. For part C, Owen writes another expression, radical x. We want to know what value Owen should use for x to make this expression equal to his first expression. So recall that he got 4 from his first answer. That was from part B. We already did that. So we basically want to set radical x equal to 4. Now, to undo the square root, we have to square both sides. So that'll give us x on the left side, and 4 squared on the right side is 16. And then just double checking real quick mentally, if I square root 16, I do get 4, so we're good to go on this. For this part of the problem, we want to write an expression that could be Peyton's expression, based on the fact that Peyton is writing an expression that has a cube root and an exponent, and it's equivalent to Nora's expression. All right, so unpacking all of this. What was Nora's expression again? Well, whatever it was, it came out to 3. So we need to write an expression that has a cube root and an exponent and comes out to 3. There's lots of lovely possibilities that we could use. Probably the easiest would be to first take the cube root of 3 and then raise it to the 3rd power. Since cube root and 3rd power cancel each other out, this would give us 3 if we evaluated it. For this question, we have a table that's being used for multiple problem parts. The first part is asking which of the following function descriptions best describes f of x. So there's two things going on in these answer choices. We're talking about decay and growth. So it would be good to see if our function is essentially going up or going down as the x values increase. And we see that it is growing. Now, the other thing that we have to keep in mind, because we've eliminated choices A and C at this point, since those were both decay, we have to see if it's linear or exponential. Basic idea here is linear. Every one value that your x value goes up, your y value keeps going up by the same amount. With exponential, you keep multiplying by the same amount instead of adding the same amount. So what this looks like in practice is the exponential is going to grow a lot faster than the linear, and it's not going to be the same rate of growth for the same distance. So just looking at our table here, we have an increase of 3 in the x value, and that gives us an increase of 101 in the y value. Now, once we increase from 3 to 5, an increase of 2, that then gives us an increase of, well, over 300, right? 312. So if you're growing more despite having taken less of a step, then you obviously don't have the same rate of change. So this would be an exponential increasing rate. So we're going to pick choice D then. For this part of the problem, we want to know which of these functions models f of x, at least based off of these 3 values here. So you could hypothetically just plug 0, 3, and 5 into all of these functions until you found a function that gave you 13, 104, and 416. But you can actually save a little time if you look at the functions in the answer choices. For example, in choice A, 2x plus 13, this is an mx plus b type of situation. This is a linear function, not exponential. And we already saw from the last part that we were looking for an exponential function. So this one is definitely not going to be it. It's the wrong type of function. Now, b does give us an exponential function, one where the variable is in the exponent. Is it the correct exponential function, though? So this you can test out by plugging your x values in here and seeing what happens. If we do 13 times 2 to the 0 power for that first entry, well, we have to do the exponent before the multiplying, so this 2 to the 0 happens first. Anything to the 0 is 1, so this is really 13 times 1, or just 13, which is what we would expect. Now, we could keep going and plug in 3 to see if we get 104 and 5 to see if we get 416. Those numbers are getting bigger, though, and this is the no calculator part of the test. So I'm going to keep going with my answer choices, and if I can eliminate the rest of these, then I'm going to pick choice B. So for choice C, that one is also linear. We have an mx plus b setup, so this couldn't be it. We can eliminate C. D looks kind of exponential. We have an x minus 1 in the exponent. Let's plug in 0 and see what that gives us. So if I plug 0 in here, I've got 91 times 2 to the negative 1. 2 to the negative 1 is really the reciprocal of 2, or 1/2, as it were. So we're doing 91 times 1/2. Now, whatever that is, I know for certain that it's not 13. It's not even a whole number. So since that's not 13, that means D can't be it either, and we have to pick choice B. For this problem, we're looking for the solutions of this equation. This one is, you could plug in your answer choices and see what makes it work, but this one's actually pretty quick to solve just on its own. So since we have something that's already factored, we have a product and we have 0 on the other side, we can use our zero product property, where we set each of these factors, 2x and 3x minus 4, each of them equal to 0. So I can write 2x equals 0 and 3x minus 4 equals 0. And now I just have to solve each of these little equations to get my answers. So this equation on the left, if I divide both sides by 2, 0 divided by 2 gives me 0. So x equals 0 is one of my answers. So I can eliminate any answer choice that does not have that, such as C and D. And then over here, I have to add 4 and then divide by 3. So I have 4/3 for that x value. So that ends up giving us choice B. On this problem, we're told in a geometric sequence, the second term is 15 and the fourth term is 135. So we want the first term in the sequence. The key on this one is remembering that for a geometric sequence, we keep multiplying by the same thing over and over again. So that means there's something I can multiply the first term by to get 15, and then if I multiply by that same number 2 more times, since it's fourth term next, then I would get 135. So you really just kind of have to test a few things out. So let's say that the correct answer was A. I don't know for sure, but let's try it out. To get from 3 to 15, I would have to multiply by 5, 15 divided by 3. If I multiply by 5 again, that brings me to 75, and that's the third term. Now if I multiply that by 5 one more time, I'm not sure off the top of my head what that is, but I know it's going to be way bigger than 135. So I can say choice A is definitely not the right answer. Let's look at B now. If I start with 5 and I get to 15, that means I must have multiplied each time by 3. So let's see what happens if I multiply a couple more times by 3. 15 times 3 is 45. And then 45 times 3, feel free to use some long multiplication if you need to. 3 times 40 is 120. 3 times 5 is 15. 120 and 15 gives us 135. So we do have a fourth term of 135. So it's looking like choice B is going to be our answer then. Now, you could test out C and D. They're a little tougher to test out, though. I mean, what times 7 would give us 15? I think it's 2.5, but if you multiply 2 more times by that, you're going to get some other crazy decimal, not 135. And you would have to do 9 times, I believe it would be 5/3, 1.6 to get 15. And again, that's unlikely to get you 135 if you keep multiplying by that. On this problem, we have a candidate receiving 59% of the votes in an election. And in the election, only 76% of 39,881 registered people actually voted. We want to know the closest to the following number of people who actually casted a vote for this candidate. So there's 2 levels going on here. We only have 76% of this total who actually voted, and of those people who voted, we're saying that 59% voted for this one candidate. And we're just trying to find the people who voted for the candidate. So we first have to figure out how many people voted, and then we'll have to multiply that by a percentage that gives us the people voting for our candidate. To make our lives easier, since this is a no calculator kind of question, we need to round some of these off a little bit so that I can use the numbers. So 59%, I'm going to call that 60%. Even that might be cutting it too finely, but I'm going to go with 60 and see if I can work with that. For 76%, let me call that 75. That's pretty close. And this total here, I'm just going to call that an even 40,000. Given how far apart these answer choices are, if I use these numbers, I ought to be able to get closer to one of these than the others. So first thing I need to do is figure out how many people actually voted in the election, regardless of who they voted for. So I need 75% of 40,000. So 75%, that's 3/4 of something. 3/4 of 40,000 is going to be 30,000, so that's not too horrible. Next, I need to figure out of those 30,000, how many voted for my candidate here. So I need 60% of 30,000. Now, this is a little bit trickier to work with, but one trick you can use, since 60 is a nice multiple of 10 here, let me figure out first 10% of 30,000. 10% of 30,000, I just have to move the decimal left 1. So that's 3,000. And then to get 60, I can just multiply that by 6. Gives me 18,000. So that'll be choice D. For this question, we're actually going to do 2 questions based off of this system of equations. The first question is, what's the solution? Solve the system of equations. So there's a couple of ways of doing this. One way to do it, called the elimination method, would be to add these equations together in such a way that one of the variables would cancel out. So to make this work, you probably have to multiply one of these equations by a number. Like if you multiply this first equation by 2, you would have a 2x and a negative 2x that would cancel when you added these. Another way to do it is using substitution. I'm going to use the substitution method on this because I have variables like this x and this y that look like they're pretty easy to get by themselves. Let me just get this x by itself here. So let me rewrite both equations. Just haven't changed anything yet. But now in this first equation, let me get x by itself. So I'll subtract 2y from both sides. So now wherever I see an x, I can replace it with an 8 minus 2y. Over here in this second equation, let me replace this x with 8 minus 2y. So now I'll rewrite this as negative 2 parentheses 8 minus 2y, close parentheses, plus the y that was already there equals the negative 6 that was already there. Now I just have to solve for y since I have a single variable. So I've got negative 2 getting distributed. That's negative 16 plus 4y if I distribute to both of those. And I'm going to do 2 steps at once on this next one here. So I can combine these y's together. 4y plus y is 5y. That's on the left side. And I'm going to move this 16 over to the right side just to get all the constants in one place. So I have to add 16 to negative 6. That's going to give me positive 10. And that works out nicely because 5 divided into 10 gives me a y value of 2. Now that I've got my y value, I have to plug it back in to get the x value. I can plug this 2 into this equation over here that I created that has x by itself. So I can rewrite this as 8 minus 2 times 2. And then this is 8 minus 4, which means we have x equals 4. Now the answer should be written as a point, so I'm going to write this as 4, comma 2 for my final answer on this one. On this next part of the problem, they want us to graph the system of equations. So to do that, I'm going to have to put both of these in y equals mx plus b form. Taking a look at my first equation here, I'm going to subtract the x because I need to isolate y to get it in y equals form. And then I'll divide both sides by 2. So that'll give me a y on the left side, and that'll equal, let's see, I can write negative 1/2 x, negative x divided by 2. And we have 8 divided by 2 giving us a plus 4. So there's one that I can graph. In fact, let me go ahead and graph this one right now. Why wait? So we have a y-intercept of 4. That's our b value for y equals mx plus b. So 4 on the y-axis right there. And then here's my slope, negative 1/2, the m value. So that means I'm going down 1 and right 2. So starting at the y-intercept, we go down 1, right 2. And now I just draw a line through those because I only need 2 points to draw a line. All right, let me also graph this other one here. So I'm going to add the 2x to both sides to get y equals 2x minus 6. And there's nothing else I need to do in terms of rearranging. This is good the way it is. So now I have a y-intercept of negative 6. That is down here. And this 2 here is telling me I have a slope of up 2 over 1. So starting at my y-intercept, beginning here, we're going up 2, right 1. And if I keep doing that, it looks like I'm going to end up at this spot right here for my intersection, which is 4 comma 2, and that actually matches what we got solving this algebraically on the first part of the problem. So that's a good sign there. On this problem, we have Liam waiting tables at a diner, and this scatter plot here is showing the relationship between the amount of the bill, the check they call it, and the amount of tip that Liam actually receives based on that starter amount. Now what they've done here is they've drawn a line of best fit for this scatter plot. And they want to know, based on the line of best fit, what's the closest to the tip that Liam should get for a $25 check. Because you'll notice that we have all these values here, but we don't quite get to 25 on the grid line. That's like half a grid line. So what I would do here is take a look at my line of best fit and figure out where I am on there. If I'm at 25 for the check, then following that up to the line, I should be right about here for the tip. So following that over to the y-axis, looks like I'm about halfway between 4 and 5. So that's roughly $4.50, which is exactly what one of the answer choices is. So I'm going with choice B. For this one, we have an airplane reaching an altitude of 9,000 meters and then descending at a constant rate of 625 meters per minute. So we want to know which equation can be used to figure out y, the altitude, after x minutes. The key here is they said that we're descending at a constant rate. If you have a constant rate of change, that describes a linear function. So we're going to want something in the form y equals mx plus b. So the b value, that's typically your starting value, the value at time 0. We have an airplane reaching an altitude of 9,000 and then beginning to descend. So time starts at this 9,000. That's our starter time. So our b value is going to be 9,000. And it's going to be a positive 9,000. So that actually already narrows it down to choice B. But if we want to keep going here, just figuring out a little bit more, if we're descending at a rate of 625, that means that our meters is going down, so we will have a negative slope, a negative m value of 625, negative 625. Plugging all of this in then, we can write y equals negative 625x plus 9,000, which definitely describes choice B. On this one, we have a graph with three functions: a linear function, this f of x line is the purple line, a quadratic, the g function, that's our light blue line, and then the exponential function h, that's the black line here. So these drop-down menus, we're basically trying to pick the function that has the greatest initial value, and then the function that has the greatest value at x equals 50. Greatest initial value, you can actually look on the graph to see that. So just taking a look here, we have f of x being higher up than any of the other functions. So f of x starts at the highest value. Now, for the greatest value at x equals 50, this is a little bit tricky because the graph doesn't go to 50, so we can't really compare them directly just visually. We have a graph that goes to 40, and then maybe, I guess you can call this 45, so we would need one more grid line to really see what's going on. So we have to make some predictions based on the type of functions that these are. We can see that right away, by the time we've gotten to 40, it looks like our exponential function is above the other two. Now, is it always going to stay that way? It actually will. An exponential function grows faster than anything with a constant exponent. So x squared, x to the first, exponential is going to eventually outpace all of those. Even if it starts at a lower value, eventually it's going to win. So since our exponential grows the fastest, we're going to make a prediction that h of x must be the highest function by the time we get to x equals 50.